couple of forms. They can have limits of infinity and negative infinity. It could have one good number and one infinity. All of those are called improper. They can also be infinite discontinuities, and they can be at an endpoint or within. Let me show you an example. Suppose you looked at something like 0 to 4, 1 over x dx. The reason that's improper is because, you know, earlier today you asked me about that 0 from the right and 0 from the left. This function from the left and from the right doesn't go the same place. So this thing is called an improper integral because the function has a vertical asymptote right there. So the vertical asymptote can be at the bottom limit of integration, the top limit of integration, or sometimes they're really sneaky and they'll put it in between. 2. At 2, we have a vertical asymptote, and so it's a problem. Now, calculators will often work them, and sometimes they get the right answer, and sometimes they get the wrong answer. But the student who's unaware of this whole idea of improper integrals, of course, they believe what comes right out of the calculator, and F it. And I've even seen people do these, and what the students tell me is they use something like 100 for infinity, or they'll use negative 100 for negative infinity, and they do pretty decent with it, but I can't guarantee it. It's not really what the theorems say. So we're going to start with these type, and what we do is we use what's called a dummy variable. What we do is we replace, now I'm just talking these top ones to begin with. You're going to replace the infinity or the negative infinity with, say, a b, and it doesn't have to be the letter b, but some dummy variable. You integrate using the b in your integration and your fundamental theorem of calculus, and then you take the limit as b approaches infinity. If they give you one that's negative infinity to infinity, that one gets broken into 2 pieces. So you might run negative infinity to, say, 0, and then 0 to infinity, and make 2 separate limit statements out of it. So that's the basics. Let's work a problem, and you'll see better what I'm talking about, I hope. Okay.